All right, everybody, welcome to Earth Science. Here we go with page 8. Again, even though my page numbers themselves have gotten a little bit off, I rearranged this. No big deal. We're going to break it down to two specific kinds of isolines. So isolines is like the generic word for all of these lines that we're drawing. And then we'll get more specific and say that there's isobars and isotherms. And there's a ton of other ones. Type it into Wikipedia, you get a whole list of like all the different types of them. So, of all those, the ones that we're going to concern ourselves with here in meteorology are ones that connect points of equal pressure. So we're going to have maps that have a whole bunch of pressures on them where we have to deal with drawing these isolines, or temperature. Same deal. Maps with a whole bunch of temperatures on them, and we'll have to draw these lines. If you know your prefixes and suffixes, therms should ring a bell, like a thermometer is going here with temperature. So these ones, the second one down, are isotherms for equal pressure. Those are the isobars. We use a barometer. We measure in millibars. Yeah. Now, they're going to look different, though. That's going to be the trick to this, and that's what I'm going to ask that we try to get out of these next two pages. I'm going to do 2 pages at once here. One, so because we got a little bit of each on each one. They look different, and we got to learn to recognize these patterns. For today and for like this week, that's not going to be a giant critical issue. But as we start to get into the labs and the work we're doing with weather, you're going to want to be able to spot those and just discern between which one's which fairly quickly. It's not as complicated as I'm making it sound. I should just stop talking, right? I heard you. All right, general patterns. Temperatures are generally colder. Near the poles. Believe it or not, colder has a D in it. And warmer near the equator. That's stuff we know, right? We've always known that. You didn't need me to tell you that. Therefore, the temperature blank, as you go from south to north across the United States, it decreases. Therefore, isotherms like mimic that pattern. What an isotherm is, the nature of the line, it's going to be the shape that it is because of that relationship, because up here it's colder. So maybe I'll say we're going to pick a very boring weather day and just say that everything's pretty consistent in the United States. Up here is our 20 degrees Fahrenheit ISO line. And then as you go south, it gets warmer and warmer and warmer. There's our 30 degree ISO line. Okay, let's do a couple of these just to, yes, you should be doing this in your notes. There's our 40. And our 50. Now, granted, there's probably more of a difference than at a given day, but I'm saying here's the weather on this day. The temperature ranges from, what? Cammy freak out. Everybody panic. All right, we're back. From 40s to 50s. Sorry for that. Cammy likes to freak out once in a while. I think it has to do with no right clicks on these Chromebooks. I accidentally do it because I don't know how to do it. So cooler temperatures up here, warmer temperatures up here. So the lines have this pattern. Now, if there's a day, and if we do the big heavy weather lab that I usually do, I haven't decided yet. What happens on the day of that weather that we look at is that cold air pushes down from Canada like that. So what you would see is in that instance, the ISO lines will like bend along with it. Like this 30 will go down like that. Of course, I'm crossing lines. I'm not saying this is what it's like today. But still the pattern's about the same. All that isotherms do is separate out the colder temperatures that are generally in the north from the warmer temperatures that are generally in the south. So what you look for, long and short of all my babbling here, is lines that go across like that, parallel to each other, separate colder from warmer. Those are most likely your isotherms because of the patterns that are like easily recognizable. It's colder in Minnesota than it is in Texas. Okay, pressure though doesn't follow those rules. Pressure doesn't have to follow those rules. So again, it's warmer towards the south and colder to the north. But pressure does not have to follow any rules like that. Pressure systems wander around, I'll say, wherever they feel like. That's not really a thing. They don't have feelings. But through all of the prevailing winds and things going on with seasons and migrating wind belts and blah, 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 these pressure systems are going to move around and do their thing. Okay? They're like the free spirits. They just don't have to follow. They're not bound to latitude in the way that temperature is. So they can just kind of be wherever, like on any given day, all other things being equal, unless you want to go and study all of meteorology first. Let's just say they can just be wherever they darn well please, right? They're just going to be in spots. And yeah, we're going to figure out how like the jet stream affects it and the wind belts affect it and the seasons affect it and blah, 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 blah. But for today, let's just say they're in spots. So this pattern it ends up not being like isotherms, which are parallel lines. Instead, you tend to get circles, not mathematically perfect circles, but the kind of blobby circles that we've been doing up above on all of these isolines. So to say, hey, well, what is it like on those days? Let's just pick a spot. Let's put an H right here in Colorado. So that there's a high pressure system. We are not to a point in meteorology where we understand yet in our studies what a high pressure system means. There's a lot that goes along with it, but we're ignoring it. And let's put a low pressure center. Same disclaimer, we don't know what that is yet. Right here in upstate New York. What ISO bars, the lines that separate high pressure from low pressure would look like then are more like circles going around these systems. So I'm going to draw, I don't know, 3 of them-ish here. Drawing fast, they shouldn't be that angular, but whatever, it's cami. Maybe there's one like in between the high and the low that's so big it doesn't really fit on our map, so that'll just kind of be a separator one there. And then around the low, maybe there's a couple more. My task, the thing that I'm asking out of you is, can you see how this pattern is different than the one we drew on the map above? If all this weather talk is intimidating, don't worry. We're all going to be okay. But can you see that difference in pattern between what that looks like and what that looks like? Okay, we can ignore my arrow here too. Whoop, killing it. Just crushing it here. There we go. Can you spot the difference in that pattern and that pattern? All right. And really, it all comes down to the idea that temperature is dependent on latitude, but pressure is not. What's likely to happen if this map that I just made up off the top of my head were allowed to progress for the next couple days is that this high that's over here in Colorado would migrate this way. This low would migrate up off the coast, up towards Newfoundland, and maybe something else would come in over here off the Pacific Ocean and work its way in. Because again, we live in the westerlies. I know I mentioned that above, but between about 30 and about 60, depending on the seasons, it wobbles up and down a little bit. But at 45 where we live, we're dead center, so it's always going to be a westerly wind belt. These westerlies will blow these pressure systems across the country from the west towards the east. And what our goal through meteorology is going to be is, excuse me, really to analyze and get down what does that do? These lows and how they interact with the air around them. There's a lot going on there weather-wise. But that's not for today. So for today, spot that pattern, spot that pattern. If you can jam in your head that those lines tend to go with temperature, those circles tend to go with pressure, we're in good shape. So which is which? I'll ask you. Cue Jeopardy music. I don't have it. There's some... All right, which is which? I would say that this one right here is isotherms. Goes with temperature. Whereas these ones are isobars. Sound good? So even though that says page 10, that was pages 8 and 9. We'll come back with more. Then we get into some more stuff with those isobars at the very least. We'll see you in a few minutes. Or take a break if you need. We'll see you soon.